Welcome back for Unit 11, Lesson 3. We are again simplifying radicals, and this time talking about the quotient property. Your objective is here. Let's go ahead and get started. This slide is just a friendly reminder of when a radical is simplified. Okay, a radical is simplified if we have no perfect square factors other than 1 underneath the square root symbol. So for example, we can break apart the square root of 8 because the square root of 4 is a perfect square. Okay, so we can still break that apart. And again, we can't have fractions underneath the square root symbol, so we can break it apart, okay, and then simplify. Same things here. We can't have radicals that appear in the denominator, so we can still simplify that. Alright, today we're going to talk about this middle part, the quotient property, and how to use that effectively. Okay, let's go and move on to the next slide. So the quotient property is right here. It says if we've got a quotient underneath a radical, so we're dividing two things under a radical, we can break it apart into the first number, the square root of the first number, divided by the square root of the second number. Or if it's written as a fraction, the square root of the top number divided by the square root of the bottom number. So for example, the square root of 9 over 25, we just simply break that apart into the square root of 9 over the square root of 25 and simplify as much as we can. Well, 9 is already a perfect square, so that just breaks down to 3. And 25 is a perfect square, it breaks down to 5. And our fraction is simplified, so we are done. Okay? This one here, first thing that I would check for, especially when you've got a number that's bigger on top than the bottom, is can these two numbers simplify? Okay? Meaning, can I simplify 18 and 2? Well, 18 divided by 2 is 9. So the square root of 18 over the square root of 2 is the same as the square root of 9, which is 3. Okay? Well, let's go ahead and do some more examples. Okay, here we got a couple examples. We've got the square root of 20 divided by 4. Now we cannot simplify this one to start with, and here's why. Because this 4 is not underneath a radical. Okay? If it was underneath a radical, then we could go ahead and divide these and say it'd be the square root of 5. But this is not the square root of 4, so we can't do that. We have to just start by simplifying the top number. Well, 20, we have to figure out, are there any perfect square factors, that go into 20? So for example, 1 times 20, no perfect square factors. 2 times 10, still no perfect square factors. 4 times 5, aha, we got one. 4 is a perfect square factor. So I'm going to break the square root of 20 apart into the square root of 4 times the square root of 5 all over 4. Again, we can't go ahead and simplify these because this is not underneath a radical. So we have to simplify the radicals first. The square root of 4 is 2, and the square root of 5 is simplified already, and we just put that over 4. Now we can think of this as a fraction, 2 over 4, and reduce it. So that would go to 1 times the square root of 5 all over 4. Or we can just simply say 1 times the square root of 5 is just the same as the square root of 5 over 4. And that's as simplified as we can make it. Now this one, I'm going to show you two different methods because there's a really easy, quick method for one like this. But I also want to show you a method in case we can't simplify, first. So for example, this fraction can simplify right away. So we can say this is the same as the square root of, and if we divide the top and the bottom each by 2, that's 16 over 25. Then we can break it apart and say, well, the square root of 16 over the square root of 25. And the square root of 16 is 4, and the square root of 25 is 5. Now, I want to show you a method, though, just in case you cannot reduce this first, and how this would break apart. So let's do the same problem, but a little more extensively. We're not going to simplify the fraction first. We're just going to say that this is equal to the square root of 32 over the square root of 50. Well, then we have to go ahead and break these apart. So we have to figure out, are there any perfect square factors of 32 first? Well, again, we can do 1 times 32. We can do 2 times 16. And if I do that, right away I see that 16 is going to be the highest perfect square number that goes into 32. So for 32, I'm going to put the square root of 2 times the square root of 16. over, and then 50. Well, we know that the square root of 50 can be broken down into the square root of 2 times the square root of 25. And now look what happens here, okay? I've got the square root of 2 on top and bottom, so those can cancel each other out because anything divided by itself is 1. Okay, so when the same number's on top and bottom and they're both under the square root sign, I can cancel those. And look at what's left. I got the square root of 16 over the square root of 25 now, which is just like I had up here. So that's going to equal 4/5 either way. Okay, so again, wanted to show you this method of breaking apart the top and breaking apart the bottom, okay, because sometimes you won't be able to simplify the fraction to start with. And let's go on to our last example. Okay, here's our last example, okay. Well, first thing we see is we've got a multiplication problem and a quotient property. Alright, well, we can take care of this in any order you want to. I always like to take care of any simplifying I can do first, okay? And I know that the square root of 4 is 2. It's asking me for the negative version of that. We talked about that in the first lesson. Okay, where that means that it wants negative 2 times negative 2 gives me positive 4. So the negative square root. And we got times, and again we got a quotient rule here. We got the square root of 81 on top, that's 9, over the square root of 36, which is 6. Well, now I'm just going to multiply these like fractions. So this is the same as negative 2 over 1 times 9 over 6. And this simplifies. Okay, so now I can simplify this again because now 9 and 3 completely simplify to 3 over 1. So now all I've got left on top is negative 1 times 3, which is negative 3. And then 1 times 1 on the bottom is 1, so I really don't need it there. Okay, so it's just negative 3. That's what that breaks down to. Okay, so it's crazy how we can take a problem that looks like this to start with and simplify it all the way down to negative 3. And that's your lesson on the quotient property. Best of luck on your homework.